Good morning, ladies and gentlemen. Also, good morning to and welcome to all our international guests that are attending this MPES 2015 Conference Innovation in Mining. I'd just like to thank the South African Institute of Mining and Metallurgy for the opportunity to present this keynote address. I basically thought long and hard about the title of this keynote. I've been working in the industry for the last 20 years. So the question I'm really asking is, has technology generated ROI? You're all familiar with the South African mining industry in terms of the productivity and the challenges that we're facing. If you have a look at this slide, the black line there shows the decline in productivity. Productivity basically being the kilograms of gold produced over the input hours per resource. And this is just a chart from gold. The same applies to all the other commodities as well. The Statistics SA and EY Productivity Mining Report from July 2014 shows that just between 2007 and now, there's been a 35% decline. And at the same time, real labor costs have been going up. What are the reasons? I mean, that decline has happened over the same period of time that we've had the commodity super cycle and the massive increase in commodity prices. So potentially volume increases at any cost due to the commodities boom, reducing grades, deeper mining, HIV, AIDS, and obviously the labor issues that we've been having in South Africa. But if you actually have a look at it in the US, there's also been a decline in the mining sector. That red line shows the decline also for that same period, 2002-3 onwards until 2012. This report comes from the US Bureau of Labor Statistics and the McKinsey report, Productivity in Mining Companies, May 2015. Now, very interestingly, oil and gas has shown the same decline, but the motor vehicles industry has shown a massive increase, and they are almost 3 times more productive than they were in 1987. So it'd be interesting to actually do some more research. That hypothesis that the motor industry was getting more productive, and I want to get my head around why and how technology has played a role in that. Interestingly, the productivity decline has even been worse in Australia. If you have a look at all the sectors, that's the black line that's moving up from 94 up to 2012. But look at the yellow line. That's, again, the productivity decline in Australia, almost 50% in 2001. It's a global trend. It's not just South Africa. It is the US. It is Australia. This chart shows you the same issues in Canada and in Chile, for example. So it's a downward trend. It also comes out of the EY productivity report. Now comes the hard part from October 2014. But if you actually look at over that period, the last 10 years, there's been massive equipment efficiencies. Just having a look at this rock drilling capacity data, between 1908 and 2005, a massive improvement in the meters drilled per hour in terms of drilling capacity. Now, obviously the improvements in equipment efficiencies and reliability over the last 10 years, massive improvements in engineering. Investment by a lot of the OEMs in their mechanized equipment, reliability of equipment has improved. Also massive investments in information systems, IT infrastructure, enterprise resource planning solutions like SAP, and mine technical systems, and all the accompanying information systems. So all of this investment, massive improvements in equipment efficiencies, and yet there is a massive decrease in mining productivity over this last decade. And really the question is why, and what has contributed to this? So recently, all the executives have been saying very similar things. In fact, the executives all around the world in the mining industry saying things about technology. I've just pulled out 2 quotes, which are obviously closer to home for me. Tony O'Neill, the Group Director, Technical and Sustainability at Anglo American, said, and this is in November 2014 when he was presenting at the Dassault Systems Conference, mining needs to leap forward 20 years in the next 5. And then last week, Nick Holland, the chief executive of Goldfields, said, gold companies must embrace technology to survive. Now, when they're talking technology, they're talking about equipment, they're talking about management information systems, they're talking about software applications. It's the whole holistic view on technology. So therefore, the theme and timing of this conference that we're at now is very appropriate. Smart innovation in mining. The intention of innovation in mining is to to really accomplish the following. We want to increase return on capital employed, which is that top variable on this slide. Now, that can be achieved by increasing operating profit or reducing the capital employed. Now, ideally, we want to increase the operating profit. So how's that achieved? Well, we must increase our productivity and production at the same cost or not as much cost as the improvement in production and productivity. Secondly, we could improve the revenue per ton, which is achieved through better scheduling, better mining, higher grades, and then a reduction in cost. There's a lot of new technologies that are coming into the fore. We've got autonomous trucks in Western Australia. There are mines that are putting a lot of autonomous trucks into the open cast iron ore mines. We've got robotics that are now able to do point cloud scanning underground and even in open pits. Photogrammetry, which is basically taking photographs and creating a mesh. LiDAR scanning to generate point clouds for as-built. There's short interval control around fleet management systems, which is now even being looked at for underground. Advances in mine design and scheduling, like the new Bentley solution that has been built with SAIMM called Mine Cycle. Real-time information dashboards. Now the big thing is real-time dashboards. There's digital control rooms to keep track of the mine real-time. And virtual reality and augmented reality. The University of Pretoria has just invested a lot of money in a whole virtual reality center, which is world-class and leading edge. And obviously a lot of spatial data now to try and consolidate and integrate the data. So has this data or has this technology contributed to efficiency improvements, revenue per ton improvements, and cost reductions? What has been happening over the past decade? I did what I generally do, and that is I went and spoke to a lot of people in the industry, went and listened and tested some of my hypotheses. And I got some of the following quotes during that process. I won't mention any names, but these are some of the comments I got. Technology for the sake of technology. Poor business process entrenched through legacy technology functional deficiencies. Employees do not know the business processes. Excel is the duct tape for all data. That was a very interesting one. And in fact, I'm starting to get involved in other industries, and I'm finding Excel is still the main predominant vehicle for collating data, in fact, for transferring data between systems. Business processes forced on business by IT. This is based on the fact that often the software applications dictate a certain business process, and those have become the norm in business. Many people have just become data jockeys. So you're finding that people don't even go underground. They don't go into the pit. They are spending a lot of their time filling in Excel spreadsheets for management to try and justify deviations or variances in production targets with more and more data. So that comes to the next comment. Lots of data, no information. Duplication of roles and data generation. People don't even understand what their roles are, and they're all generating similar data without understanding what's the definitions in the data, other people's data, what does it actually mean. Lack of understanding of data definitions and dependencies. Business can't even pull generally their own numbers now. They have to rely on a IT data specialist to pull data because of the data structures and where it's located and requirement for technical competence to do that. And lack of decisive decision-making, which was an interesting comment as well. If you have a look at all of that, there is a common theme that runs through all those comments. And I would say that it's information systems, sometimes called in some companies IT, IM, information management, ITC, information technology communications, or just technology. So I have some hypotheses that I want to present to you guys and ladies. I haven't found objective data to support this. It's really based on conversations, based on my own personal experience and discussions I've had with people. There are 4 pieces of experience I've had over the last 20 years, which sort of contributed to me trying to come up with this hypothesis. First half of my career, for the first 10 years, I worked at Anglo American, and there were 2 particular projects that I refer to here. First, worked as a young engineer on the building of the new Sadioli Hill Gold Project in Mali in West Africa. And it was in 1994. There were no computers. There was only a fax machine and a telephone. In fact, it was a satellite telephone initially. And the mine had satellite telephone, as I mentioned. And the drawing office and the design office at Anglo had CAD. So we had a room with expert systems in it. I worked as a project engineer as part of the Joneng Aquarium project, part of RAPA 2000, that used a systems engineering approach to the design and implementation and project management of that project. And that's sort of exposing me to this systems approach of thinking, which I'll talk about just now. Then the last 14 years, I co-founded SAIMM, spent 14 years developing optimization and advanced analytical solutions for the mining industry. And that experience has also been very, very valuable. And then over the last 4 years, while it's sized to fulfill the leadership role in the development of a next generation of mine planning solution in partnership between Bentley Systems, which does MicroStation, and SAIMM. And there were some great lessons I've learned in that process as well. Before the information era, I'm talking now from my own experience, there's me in the middle, Gary. I had a boss and I had some subordinates and maybe some colleagues, and you communicated via a phone call, face to face, going to their office, so basically walking around, a memo, or having a meeting. And in fact, if you sent a document to the printing pool, then there'd always be to the 3 drafts in the final version. There was this yellow copy that went to your boss so you could keep track. It went to his inbox, and a pink copy to hard copy filing. So my role was clear. I was very clear what my role is. I was in control of my own business processes because I had no dependencies on other people. Yes, a lot of manual work and paper. There was a typing pool, as I mentioned, that you had to wait 2 days to get your fax back. Hard copy filing system, in and out tray, so you could see your in tray and manage it, and you could see your out tray. And there was a computer room with standalone computers with expert systems, and anything, we had a manual switch that could switch between different computers if you wanted to print. So we had CAD, digital terrain modeling, and Quattro Pro. I don't think we even had Excel in those days yet. Then we started with the information age, and we got computers on every desk. So there's me still. I've now got a computer. My subordinate there, you see, hasn't got a computer because you didn't get a computer at certain levels. The boss got the computer first. So you still walked around. You still did memos and meetings, but you'd added this world of email that you could email. The receptionist, as a phone call, could now email you with a message. My role was still clear. I was still in control of my business processes. I could now go and do my own Excel spreadsheets. I could type my own Word documents, faxes. I could send my own emails, which were quick. Files were saved on the local hard drive. There wasn't a network really yet, which was in its infancy. There were files saved to hard drives, simple floppy disk backups, a very simple network, and you were exposed to a lot more information. You're being CC'd now on mails where previously you just faxed the person or you got only what you needed to know about. So I'd say my productivity probably increased quite substantially. Very quick to do emails. I could write my own faxes and respond to queries from the mine quickly. Excel spreadsheets. I could do budgeting very easily, and obviously the increased communications. That then progressed, and we now started putting in a full network. We had a network storage, so you could now save documents in a filing system online. And what you'll see there now is you've got now documents and files saved on hard drives, and you've got sometimes databases, and you've got these interconnections between the different databases. So my role was still clearly defined, but there was integration now between expert systems. So now one system needed data from another system, and the data you were producing was being used by somebody else. So there were dependencies now. You were dependent on somebody else doing their job. Your system was dependent on data from another system. So everybody started to become dependent on other people. It's almost theory of constraints around organizational behavior, where you now aren't as efficient because you're waiting for someone else to meet their milestones or complete their task. Also, you needed to understand the data definitions around what the assumptions were in the data and what the level of data integrity was. And interestingly, the software started defining the business process. So my business process started adapting purely because of possibly the way the software was designed by the software engineers, or by the fact that there were software deficiencies. So my productivity, I put a question mark there. I don't know if my productivity increased or reduced, but my productivity now was very dependent on other people, other systems, and data. This progressed, and this software system started being bottom-up implemented to replace functional requirements in business. So everybody now has different applications on their computers, and this whole world of enterprise architecture starts now rearing its head. And you can imagine now, when you link all of that together and everybody dependent on everybody else, we now have a whole host of solutions that satisfy individual functional needs across the whole organization, with multiple dependencies between systems, people, processes. Now, add to that the value chain and the functional areas. I mean, just looking at purely the activities in open cast, drill, blast, load, haul, crush, and process, you can imagine that dependency of all the people in their functional roles versus the applications to satisfy all the individual functional needs, now spanning the whole value chain. And you start understanding the complexities around dependencies between the systems. And this is only just at a data level. We haven't even looked at material flow from an actual production perspective, which is a topic for a whole another presentation. And now we add this world of technical enterprise architecture. And I put a question mark there because we're now looking at pulling all this data from all these different systems and throwing it into databases. So now we've got databases with potentially thousands and thousands of variables. And then we put enterprise reporting, dashboards, and digital war rooms on top of that. And we believe that we are going to give management the information to be able to make better decisions. In fact, I think it just creates more noise. And the next big thing is going to probably be also real-time operating digital control rooms. But is that making the life of a manager easier? There's more information, more emails, more noise in data. This is a slide that I just want to reference Dave Drinkwater from Anglo American. He gave me the slide. It just shows the scope of the technical systems at Anglo American between exploration, mining, processing, logistics, and support. I'm not going to go through all of that. It just shows you the extent of touch points between all the different systems, all with their own proprietary data structures, all with their own different file structures, data definitions, and now we're trying to put all that data together with different business processes as well. So these are my observations that I can conclude from my little synopsis of the information age. The mining organization is becoming more complex. We've got mechanization, which is meaning we've now got interconnected activities. So the impact of downtime and variability between activities is increasing. Therefore, we've got more data and more material variability, there is material variability in the grades and the rock types. And then there's performance variability in all those pieces of equipment and system. And that's becoming more and more complex, which obviously has an impact on productivity. There's multiple task dependencies between systems and data, what I spoke about. Spider web of integration that's organically been built from the bottom up. Overly complex business processes that are being organically built from the bottom up through the continual implementation of new technology. So what you find is that you now implement a new technology and the business process of the technology is forced onto business due to either inefficiencies in the product or the way it was built because of legacy assumptions. And these are being forced on business often by IT. Another issue is no clear understanding of the underlying data definitions and structure. Business don't understand them. It's the world of IT and it requires an analyst to access the data. So you can't just pull data readily now. You wait a couple of days. And that's why we're looking at the world of dashboarding and there's a slice and dice business intelligence tools. But we all know that might just be creating even more noise in manager's life or leader's life. Another issue is the role of IT versus business. We've gone into this information age and IT have taken ownership of business processes. They've taken ownership of the data and they've taken ownership of the business applications. And I'm going to ask this question, who should own that? Is it clear what IT own and what business own? Should IT own the business processes? I feel that business should be owning their own business processes. They should own the data because now when the data isn't correct, it's very easy to blame IT and blame the system. Business are not owning the business processes. IT are then mapping those business processes. And then business processes that have been forced on business by IT and systems. These have now become the standard. I'll give you an example in new mine planning solution that I was building with Bentley. The biggest obstacle I faced was that technology would allow us to do mine planning completely differently. The computers would allow a lot of the manual tasks to be done automatically, but the change management around trying to change how people did their job is actually the bigger challenge. We could have built the most amazing technology, and in fact, we only made an incremental change, but yet everybody just wanted to still do the same functions, press the same buttons as they've been doing for the last 15 years, when in fact there were certain functions and responsibilities that were totally redundant because of technology, but yet we were trying to almost panel beat the technology to meet the business processes that have been designed or forced on business over the years due to technology inefficiency. So it's a crazy sort of catch-22. Then continuing, I've put a point here, enterprise architecture, and I put some question marks because IT have seen this as a technical role And I'm questioning this whole thing of enterprise architecture, which I'll discuss later in the presentation. Data noise, a lot of data rich, but information poor. And we're just going to put more real-time dashboards on top of this and expect managers to be able to identify what are the variables to manage, what are the KPIs to manage to increase performance. So it ties into the next point, ineffective identification and management of key input metrics to perform. I don't believe that managers even know how to now performance manage the interconnected activities between drilling, blasting, loading, hauling, and all the unit processes. What are the main variables? It's not about managing 30 different input variables. What are the most critical variables to manage the capacity of drilling, for example, and loading? How does the impact between the knock-on effect between starving and choking between those interconnected activities actually impact the system throughput of mining? And I'll talk a little bit about that at the end of the presentation when I give you some of my views on what to do. Interestingly, applications in IT, I believe, are replacing experience, conceptual thinking, and problem solving. I've been saying to a lot of people in the last couple of years that people have become box tickers. They just follow process. They just tick boxes and the computer must do it, often with no understanding of what the actual system is actually doing. I found that when I built the new mine planning solution, this world of evaluation where you have to intersect the mine design with the resource model to pull out the grades and all the other attributes. And no one actually understood how it worked. It sits in a software solution and that's how it's been done. And you push a button and it generates the grade. And in fact, there were instances when the grade was actually wrong. Mine technical systems vendors, the software companies or technical system suppliers, often have built a suite of solutions through acquisitions. So they've purchased code and they've plugged this all together. And this has resulted in no proper integration, no common architecture. And you've now got these systems that are kind of almost glued together with, in some instances, with CSV files transferring data or ETLs that need to be run. Do management have the experience to effectively performance manage? It talks back to point 3, what KPIs matter? And then what does information management have in terms of communications, ownership, autonomy, and leadership? If everybody can see all the data, are people as confident to make decisions, take ownership, and what does it mean into leadership and judgment? Mining needs to be looked as a system. It's interconnected activities with data, information, business processes, people doing stuff, software applications, and an underlying technical architecture to support this. And that is one complete system. We need to break down the silos, and ideally what I'd like to see, instead of there being business process mapping, which is critical, and I'll talk a bit about it just now, but on the wall of the general manager's office and even in the boardroom, we should see a picture. It should be a picture of the mining value chain. Simple. If you look at open pits, it's mining, drilling, blasting, loading, hauling, crushing, processing, and then obviously the output. And we should see an integrated view. What are the main performance metrics to manage that interconnected value chain? System throughput and the associated financials. There's probably only 10 metrics, and I'll show you in a second my view. It's not a database with thousands of variables. There's 10 critical metrics. You can measure that whole thing. And then in turn, each of those activities should have who's responsible for it. What is the key performance metrics to manage? And how do those performance metrics impact the next activity, or how are they impacted from the downstream activity? And that's as simple as that. And then immediately you know exactly what is happening because you know which variables to manage and perform. This slide I also got from Dave Drinkwater. He presented at a couple of conferences, and he's got this view of an integrated enterprise system. I've taken this and I adapted it, did some reading on TOGAF and reference models that have been built in America in government to understand this technology world and the need for an enterprise reference model. I'm calling it the mining business reference model. And it's a triangle of a whole host of supporting decisions and information that makes up the enterprise, because it's not just about the technology. It's not just about the data. If you start at the very top, and that's what I'm advocating, we need to actually redesign the mining business of the future and make it digitally mature. We can't take our old manual process and believe we can just plug in technology, plug in equipment, and we're going to actually optimize our business and become competitive. So we started right at the top. What are the decisions that management need to make around this organization? What are the variables required to actually meet those decisions? So is it about maximizing value or maximizing operating profit or return on capital or cash flow? And there's a whole host of them. That in turn, working down, would inform what information we require. So what information do we require to support those decisions? That information informs what business processes are required to get that information. Now, again, we haven't spoken technology yet. This is the business process of the business. Number 4, working its way down, is roles and responsibilities. What's the role required in that business process? Who's responsible? What are they responsible for? What variables do they measure? Then we go down to number 5, which is what data are required now to support all of that. So that's now talking about actual variable names, definitions of variables, standardized glossary of terms. And now do we only go into the technical aspect of applications? Number 6 is what applications do we require now to feed that? Now, those applications, there is new applications coming out all the time. There are great startups in Silicon Valley. We've got new optimization algorithms. You really want a process where you can choose the best of breed application. And as those are maturing and advancing, we can continually be putting in the latest applications to be optimizing fleet allocations, for example, or whatever it might be. And then right at the bottom is the supporting technical enterprise architecture. That's the whole standard architecture that supports all of this. This consists of the integration technology, the databases, the communication, the backbone, all of the stuff that really supports that whole thing. One point I wanted to make was number 3 and 4 there, business process and roles and responsibilities. Often 3 and 4 in literature is called business architecture. So have a look on the right there. I'm advocating that the technical architecture is owned by IT or information management, if you want to call it that. The rest is owned by business. Business must own their business processes. IT can supply the technology for actually documenting it, like CaseWise or ERIS, and the standards, but business must map their processes and they must own their business processes. The data, business must own their data. They're responsible for the data integrity. IT, again, can supply the frameworks, the standards, the databases, the infrastructure to support that. And a systems approach to the business design, and it consists of everything from the top down. And I would say we need to relook at the complete mining organization of the future. Really, you could call it a mining blueprint, for example. Starting at the top, we're talking about the decision. What is the decision? Well, based on market conditions, capital constraints, demand, commodity pricing, it could be anything from maximizing operating profit to a production target or maximizing production efficiency. All changes based on market conditions. For example, before the global financial crisis, it was always about maximizing value. There was a lot of capital expenditure, often at lower than ideal margins, which may have contributed to some of the challenges we face now in the mining industry. So the overall reference model must take into account the fact that the decision may change and the objective function of the business may change. Here's an example of the information required now. This is in the form of a hierarchy. SAIMM is doing some great work in the world of value driver trees, which is just visually representing these variables. So look at the very top, we've got ROCE, return on capital employed. And I'm showing how all the variables feed up into return on capital employed. You can see tons, mill, grade, recovery, all the ones in yellow, exchange rate, then you've got all the different types of mining cost. You don't need it more complicated than this. You might want to break it into geographical reason. And the tons milled is what the value chain, there you see at the bottom, the value chain, it's what the value chain is delivered in terms of tons milled. And that's the input into this. So this is an overall view of the overall business. So just looking at hauling, again, here's a hierarchy of the data. On the right-hand side there, you can see direct operating cost, and on the left, you've got throughput rate, and those two multiplied together give you the production that activity can do in a period. It could be in a shift, in a day, in a week, a month. On the right-hand side is the direct operating hours. That is actually the time model. Now, you'll find every mine you go to has got a different time model. You go across some of the big mining houses, and every operation's got different time models, different definitions of their time model variables. But it should be a simple, standard model. It should become an industry standard that when we talk availability, everybody knows what it is. If you have a look there on the right, we've got unutilized hours. And again, you don't need any complex real-time reporting of data. If that activity is now got unutilized hours, there are only 4 reasons why. Either an external delay, it could be a flood, it could be rock fall, it could be weather related, anything that's external to that value chain. Then there's internal delays. So now you've got a piece of equipment. It's been maintained. You spend a lot of money in keeping its availability up. And it's been delayed because of a shift changeover, lunchtime, because of an operator not being available. And that can directly impact the production that's achieved because it's impact on direct operating costs. And then starving. Is that activity not being fed material? So this is hauling. Is the loader down? Then it's a starving delay. And a choking delay as well. The truck is loaded. It's been able to drive to the crusher, but it can't tip on the crusher because maybe there's a blockage, the crusher's down or something. And then left-hand side, you've got throughput rate, and you can calculate that for any activity, whether it be drilling, blasting, loading, hauling. There's a methodology for calculating that throughput rate. Again, it's not complicated, not a lot of variables, and I think this is how we need to look at it. What is the minimum variables required to effectively manage the production? That's really the KPI, and those yellow are input variables that are required to measure your output KPI. Then looking at the business architecture, which is at point 3 and 4 together, there's some great work done, for example, by the Open Group. If Mike Woodall was here today, he'd have a couple of these in his briefcase and be handing them out. The Open Group has generated the mining reference model, which is sort of a level 1-2 standard reference model, which takes the discover, establish, exploit, beneficiate, and sell and rehabilitate processes, made them generic for mining with the associated processes in each one of these. Now, ideally, every mine should take this, adopt it, and make it relevant to their mining operation and fill in the relevant glossary of terms, take it down to the detailed business processes, roles and responsibilities, and then build the underlying information model that supports this. I believe the mining industry needs to generate a standard mining information model. There are other industries that I believe do have it. Doing some research currently, I understand that the electrical generation industry does have it. Basically saying that if we generate a standard mining information model that everybody can subscribe to, we can get to the point where everyone that supplies equipment, anywhere where we've got data transfer, whether it's from planning, whether it's from actuals, from mobile devices, from equipment, the data definitions must be the same. So, for example, irrespective of whether you buy a resource modeling technology from Datamine, their new Studio RM, for example, Vulkan or old Datamine, a resource model data is the same. You've got a block ID. That block has got a dimension, sizes, it's got attributes like density, grade, and that's standard, irrespective of the system. Same with mine design. Mine design is an element. Element has dimensions, and those dimensions can be used to calculate a volume. So again, it's standard irrespective of whether you're using CADS Mine, whether you're using Mine Cycle from Bentley, the data is exactly the same. I want to get to the point where you can plug in and plug out the best of breed application, depending on how technology is advancing. If the next big thing in mine scheduling is some automation or automatic rules-based scheduling with short interval control, we must be able to unplug it, plug the new thing in, and the data definition is very simple. You have an excavation, you have an activity, and it has an advance rate, and the excavation has a size, and that's standard. There is an information model for construction and engineering projects called BIM, Building Information Model. I'm talking about building an information model for mining. It would be great to call it Mine Information Model, MIM. Now, this is divorced from the underlying actual integration technology. So whether a mine got a full enterprise services bus or it's a smaller operation that's maybe just got a couple of databases, whether it's using the latest Microsoft POS integration technology to the cloud, that standard mining information model can still exist and allow the plug and play of any best of breed application. And that's really the way that I'd like to see the industry moving. Another important aspect is this role of the enterprise architect. I think there's a new role. I'm calling it business enterprise architect role. It's probably the most critical role. It's not a technical role. The mining business domain and IT domain integration role in terms of systems thinking. This person needs to basically pull together all the business domain information. When I say information, I'm talking about making sure that that reference model ties in with the IT domain. They don't have to be technically competent. They don't have to understand everything about mining, but they must be able to integrate the IT and business domains into a single world. And that's really systems thinking. I have a view, in fact, that the general manager of a mine of the future, you'll be very different from the current general manager. Current general managers are people managers. I believe in the future, the general manager is going to have a lot of systems experience, because a mine is going to be an interconnection of technology, systems, information management, data integration, and they're going to have to understand the complexities around systems, because you might find a lot of automation and a lot less people. So in summary, has technology generated ROI? I mean, innovation and technology is critical to the mining industry to remain competitive. I think we all know that, and all the presentations that happened yesterday have demonstrated this, and the ones that will happen today if you look at the program. But organizations are going to get more complex in terms of their control, talking about leadership, performance management. What variables do we now control? Even a real-time process where it's basically a factory where you've got equipment moving around and faces moving continually. Data and system integration and information systems. So MPES 2015 is showcasing a lot of the latest smart innovations from universities that are presenting papers, mining companies, consultants, and a lot of technical solution providers globally. These new technologies, such as point clouds, with some great work there being done by able to fly, for example, a drone or even a gyrocopter over a pit and getting a digital terrain model from that pit within a few hours. Virtual or augmented reality, which University of Pretoria is leading. Rules-based mine design and scheduling, new resource modeling techniques, dynamic scheduling, underground fleet management, robotics, autonomous trucks, or scenario planning, geospatial data, and the ability to capture all this real-time information, all as the opportunity to add significant value to the mining industry. But I do believe that we need to look at this thing holistically. Just putting in technology for the sake of technology, as we quoted at the beginning, isn't the answer. To make a quantum change in the mining industry will require a more holistic view, and we need this business enterprise architecture view of the business and redesign the mining business of the future. And really, on this continuum of digital maturity around the information age, what does the new business look like? Business processes are different. Roles and responsibilities are different. The people skills and experience is totally different. Every aspect of a mining company will be different. It's going to be high tech. You may sit in a suit in a control room and operate a piece of equipment 8 kilometers away. So there's a completely new look to how mining is done. So really, redesign the mining enterprise, the 21st century mining business reference model. We also need to integrate and clarify the role of IT versus business. And this is just a maturity as we go into the information age to understand exactly IT's role versus business role. For example, as I said earlier, business must own their business processes and the data. This is my view. And IT should own the technical sustaining architecture supporting the architecture. We need to design this role of a business enterprise architect. It's the systems thinking. Maybe university courses need to change potentially. We need to develop a standard mining information model. This will need collaboration in the industry. It needs to be adopted by all the mining companies eventually. And yes, this is going to take time, but we need to set the intention now. And my last point, I put a few question marks there, increase the role of industrial engineering. I've been hiring a lot of industrial engineers in the last couple of years, and I'm finding they do have the systems thinking approach. They understand the interconnected activities of a value stream and the need for integrating business processes. So potentially bringing more industrial engineering skills into the mining domain. All of this needs industry collaboration. I think that's critical. No single company, no single vendor, no single individual is going to be able to achieve this. It will need people to have a certain level of maturity because vendors are going to compete. Companies see that they have a competitive advantage. But I think we need to collaborate more so that we can drive change and make the industry more competitive. I'd like to just thank the people that I chatted to. I won't mention their names, but they all know who they are. In Anglo-American Platinum, Datamine, Jess, who're doing great work with the point clouds in a lot of open pit mines around South Africa, AussieSoft, SAIMM, in my 14 years of experience there, some people at De Beers, the Southern Institute of Mining Metallurgy that's given me this platform, and then obviously my new startup tech business called NXGN. I believe technology has a very, very important role in the future, and that's why I've taken the risk of actually starting a new tech startup called NXGN. So I wouldn't have taken that if I didn't believe in it myself. If there are any questions, please feel free to email me as well, and I'm more than welcome to have a debate with you about any of these points. Even if you'd like to see this presentation, please feel free to send me an email. Great. Thank you very much.